supposed to have started at 7 a.m. And there's been a slight change in your timetable. From 7 to 9, you were supposed to have had introduction to business administration. And the facilitator was Dr. Gladys Nkrumah. And then you were also supposed to have my course, Introduction to Mathematics, at 11:30 a.m. to 1:30 p.m. But there's been a swap of time. So going forward, instead of doing the intro to maths at 11:30 a.m. to 1:30 p.m., we'll rather have it at 7 a.m. to 9 a.m. as your first course for the weekend. And then Dr. Gladys Nkrumah will take you Introduction to Business Administration when it's 11:30 and then end at 1:30 p.m. So we can start now. I want to welcome you formally to the Institute. And I know you've gone through all the necessary orientation by the capable handlers in the Institute. So if you have any issue, you can let them know as quickly as possible, and then we can resolve it. If you also have an issue with the course that we are about to undertake, you can also feel free to contact me on my number. I'm building your learning management system for you. It should be ready before next weekend. So everything you need for your self-studies, I will mount all of them before next weekend. But in the time being, we want to start officially with this slide presentation. So as you have on your timetable, the course title is Introduction to Mathematics. And then in this institute, every course has something we call a course code. It's like an index number. It's like an index number to the course title. So our course code for Introduction to Mathematics is MATH 133. And this code, you will see it on your official question papers or any assignment I give. If you see the code MATH 133, it means that we are dealing with Introduction to Mathematics for your program. And then the session, as you also have on your timetable, a mixture of online and face-to-face, as indicated on your timetable. And then if there are any other thing that I want you to know, I'll mount all of them on the LMS system and you have access to them. We want to begin with our course outline for this course. Course outline looks like the syllabus you were following at the lower levels. That is the first cycle and second cycle. It gives us an overview of what is expected from us in terms of course expectation and the course structure. So I will just flip through them, and then where there are major highlights, I'll just speak on the major highlights. And then when you have enough time for yourself after the class, you can quickly go through the other ones that look more of like a literature. So the first slide shows my information. The course I'm teaching you, the level, the academic year, my full name, my office location, my contact number, my email address, my office hours. And so for the lecture days and time, I have written here as stated on the timetable. So we are strictly going to follow what is stated on the timetable. And then in the course of time, take your time and read about the course description, which shows you the reason why you have to do this course. And the emphasis is on integrating theory with practical applications in human resource management and informatics. So maybe when we advance somewhere, we may be taking scenarios whereby we may have to do some empirical calculations to justify our empirical evidence when we are taking decisions in human resource management. And then you also have the learning objectives. You take your time and read through the learning outcomes, same. And then this slide is also important, the course requirements. At the end of the day, if you have a computer or if you have a laptop, that would be okay. For now, we wouldn't need it for this course. But probably if I'm to teach you in level 300, we may need a laptop or a computer to be able to help us process some data and then relate it to real life scenario. But what is important for me that everybody must have before we end this course is the calculator we will use. It's a non-programmable calculator with this name, FX 991 ES Plus Scientific Calculator, Casio. That is the exact calculator that is used at the SHS level. And I hope most of you have seen it before. Some have dark gray color or ash. And so if you have yours already, that's okay. If you don't have, you need to buy one. And then, of course, the third one, I presume everybody is having any brand of mobile phone that you can use for your online lectures as we are doing currently. So once you are connected, it gives me the impression that you already have the tool that you can use for your online lectures, as well as any assessment I want to do in the form of assignment. Once it is hooked on the web, I'm sure you can access it through your tool to be able to participate. And then the fourth is that at this level, I presume you know what an addition sign looks like. You know what a subtraction sign looks like. You know what a multiplication sign looks like, as well as a division sign. These are the basic operational signs that are used in the computation of expressions. And I'm sure you haven't forgotten about them, how they are applied to intersect situations. So if you see me write 3/4, I'm sure you understand 3/4. If I change it and I make it 0.75, I'm sure you understand 0.75. That is what I mean by you having basic understanding or knowledge about communication of numbers and operations of numbers. Then there are other course policies. It may not apply to you online. These are when we have face-to-face sessions. This is when this policy applies, but it doesn't apply online. And then the teaching and learning method most of us use is student-centered. We don't see ourselves as an authority figure and then playing down on your knowledge. What we do is we learn together. We learn together. And at the end of the day, learning should take place. That is the objective. at the end of every session, learning should take place. You should be able to learn something new. There are some additional reading materials that can augment what we have already. If you have more time, then you can look at these essential readings and recommended readings, which can have a lot of questions or activities that can really sharpen your skills in all the topics we'll be doing. Ideally, this is the course assessment procedure for my course. Assuming we were meeting face to face, but because we are using a hybrid delivery system whereby we do online and once a while face to face, it may not apply to the latter. But this is the idea. You'll be assessed on the course by me giving you assignments to do, and then you may have to write a mid-semester if it will be done physically. If it is online, I'll find another way to do that. And then, of course, your final exam will be a physical or in-person exam. You'll be here. The max allocation for this course is that all the assignments are graded as 20% of your total marks to have. And then the mid-semester, which looks like a class test, also has a maximum of 20%. And then the final exam is 60%. So when we put these three types of assessments together, this should give you your 100%. It means that for all these segmentations, you have a lot of marks to fight for in order to have a good grade. The marks you have here is proportional to the grade you are going to have. And so in this school, we have our grading structure. Because I'm the first taking you for this weekend, I just want to give you an overview of how the gradings will be done finally. So this is our grading system, the GCTU grading system. And we have the range of marks that gives you the appropriate grade. So if you have any mark range at the end of your semester examination, whereby in my case, after combining all your assignment marks, combining all your mid-semester marks, and then adding it to what you have in the final marks, these are the kinds of total marks you may get. So if you score between 100 to 80 marks, the school grading system will give you a grade A. If you score between 79 to 75, the school grading system will give you grade A minus. And then if you score 74 to 70, the school grading system will give you B plus. So it continues in that order. And what I want to encourage you is that your worst case scenario grade should end up here. You shouldn't go below this line for two reasons. When you go below this line, you may not be able to make the final grade you need to read your master's degree if you intend doing, and which I will encourage you to do. Because if you are spending 4 years to do this program, you are spending 4 years to do this program. And this institute that has given you admission has a lot of master's degree programs, out of which you can even get one of them that you may spend less than 2 years, maybe a year and a half to finish your master's, then I will encourage you that don't stop after the 4 years. This institute has made things very flexible in such a way that instead of you traveling all the way to maybe KNUST or UCC to have your master's, you can have it here after your degree. So if you want to do your master's degree, which you may not spend more than 1.5 years, if my memory serves me right, then try as much as possible that at the end of the 4 years, your final marks, which will give you, we call it cumulated average. Your cumulated average should not go below this line. It should not go below this line. If you go below this line, you may not be able to read your master's if the merit-based system is being used. So try as much as possible that worst case scenario, you'll be here. And it takes a very long drop to get here. If you are not getting your A's, which is this and that, and the B, you have 3 categories. You are not getting B plus. You are not getting B. You are not getting B minus. As for C plus, it is possible to have C plus. As for C, this is also possible with hard work. Let me create a scenario for you. I told you my assignments are graded 20%. My mid-semester are also graded 20%. And then my final semester paper, which is mandatory by the school, is graded 60%. Let's see how possible you can be in this range without going below this range. Assuming my assignment, you do it well, and then you score 15%. And then the mid-sem also, let's say things did not go well. So probably you had half of that. You had 10%, making 25. So it means that you need just 25% here to get your 50%. And that looks pretty easy because if you have 25% here, even though if I score it 25 over 60, that would have been a bad performance because you had less than half here. 30 is supposed to be half, but you had less than half. But because you were serious with your assignments and mid-sem, that has pushed you to the zone that I'm recommending. So please, let's all try and work hard and stay worst case scenario in the region I have demarcated. Don't go below this region. And I can assure you, once you stay there, you can be able to do your master's degree, which I recommend with this institute. So even though you haven't gotten there, please plan ahead that you are not finishing school after 4 years. You push up to the master's degree. Then the learning management system, I'm sure you have been given orientation about it, or there is a facilitator who will walk you through how to navigate the system. It's a very simple system. So it will be your responsibility as part of your studies to always visit the LMS page to see whatever instruction that will be given. Once it's off campus or on campus, you can access it anywhere. Finally, on the course outline, I'm displaying some of the topics we would treat as a class. If you look at the course title one more time, The course title is Introduction to Mathematics. Introduction. So it means that we are not actually moving deeper. We are going to have an overview of some of the mathematics you will be doing. Unless the structure changes. If the structure doesn't change, and I still have in mind what will come, it means that you will do maths 3 years out of the 4 years. So you are in level 100 now. So year 1, you do one maths related course. And currently what you are doing is the math related course, Introduction to Mathematics. Year 2, there may be, unless the structure changes, there may be another math related course. And then year 3, also, there may be another math related course. All these are preparing you for your final year project, where you are going to apply mathematical and statistical analysis to do your project work. So it means that by the time you get to the final year, you would have gotten all the foundation from year 1 to year 3 in terms of computations, statistical computations, mathematical computations, and their corresponding interpretations. So to help us all start on the same page and then behave as if we've not been in first cycle before or second cycle before, we want to start from ground zero, from the scratch. And then I'm sure as we start from ground zero, you may be recollecting some of the things you know already, and then we can move very fast. So I'm going to start slowly, as if you don't know anything in maths. And then we can, once we take off, we can push up. And from now till 9 a.m. That we learn, we'll do a couple of things from the first area. Our first area is number operations. So we want to look at the number system and then the subsidiaries under the number system. Then we come to the applications of the number system. Wherever we get to, we can then adjourn the class to next week, where we can continue from where we will leave. So on that note, I'm done with the course outline, and then we can start with our first topic today. Number operations. Let's see what we have in the number operations. So in the number operations, we have the number system. And I want us to look at the number system. The moment we finish, we may know the application of the number system. In the business world, there are so many specialties in business, and you are doing one of them. In the business world, we have the accountants, we have those who are doing accounting with computing, we have the human resource management people, and you are doing it with informatics. We have the marketing professionals, we have the pure management professionals, we have other people doing procurement and logistics, and several units. Now, all these are interrelated and they all use mathematics or maths, because figures are used to communicate. And so it is not something new at all to your area. And we can only communicate in figures when we understand the number system. So the number system has a broad base. It is different families of numbers that have been put together to form the number system. So let's picture it this way. It's like you are living in a town, and then you look at the composition of the town. Towns are made up of communities. So you may have community 1, community 2, community 3, community 4, community 5. Different communities have different dynamics. But when you put all of them together, you have an enhanced community which becomes a town. So the number system has been given a special name that we usually call the real number system. Real number system, because we use it in the real world to solve real problems. So that is the generic name for the number system, real number systems. And they've been put into families. So you have the natural numbers, you have the whole numbers, you have the integers, you have the rational numbers. The rational numbers, an example is a fraction. And then the last community are irrational numbers. They are numbers that do not sometimes make sense on the face value unless it is interpreted very well. And an example are the decimal numbers. So let me simplify them for you in a way that you can understand it. Let's start with the first family. The first type of numbers are the natural numbers. So natural numbers are numbers that are countable. In other words, you see, natural numbers are counting numbers. Are counting numbers that starts from the number 1. Anytime you start counting, either items or properties or human being, the moment you start counting from 1, it means you are activating natural numbers. Example, if I write a set of data this way, 1, 2, 3, 4, and so on. In math, when you see 3 dots, it means and so on or continue. The moment you start from 1, they qualify to be natural numbers and no other number. Then natural numbers do not exist in isolation. If I have 200 cedis to spend, and in the morning I have 200 cedis in my pocket, and by the evening I have no money in my pocket. If you meet me in the evening and you see no money in my pocket, you may think I did not have money. But that is not the case. I had money, but I have spent the money. Therefore, I don't have the money. The number you can use to represent such a situation is 0. So anytime you see 0, 0 doesn't mean nothing. Zero doesn't mean nothing. Zero rather means there was something, but it is no more. That is why you are seeing zero. So the derivative of natural numbers, the byproduct of natural numbers, became whole numbers. And this is the definition of whole numbers. Whole numbers are counting numbers, just like the natural numbers. Counting numbers that starts from zero, whilst the natural numbers are starting from one, whole numbers are starting from zero. So example, if you see me write a set of data as 0, 1, 2, 3, and so on. Because I'm starting from 0, it means the set of numbers are whole numbers and not natural numbers. That's the distinction I want you to have. Once it starts from 0, it means you have moved from natural numbers and you are now at whole numbers. And so whole numbers are the derivatives of natural numbers. The number system doesn't end there. A third one is also propound. The third one, or the third set of numbers, are called integers. Integers. We are still working our business activity. Now, initially it was 1, 2, 3, 4, natural. And then we added 0. And then became whole numbers. Now in business, there are 3 states. There are 3 states in business, which I want you to recollect. The first state in business, which is the ideal state, is when selling price is equal to your cost price. Second state, you have where selling price is greater than cost price. And then the third state, you have cost price rather becoming greater than selling price. When you have these 3 scenarios in business, the first one, when your selling price is the same as your cost price, you don't get any profit. We say you are breaking even. So you break even here. And then when your selling price is greater than your cost price, you automatically make profit. When it comes to the left-hand side, the moment your cost price now becomes greater than your selling price, then definitely you are going to run losses. So for this game, all losses are recorded as negatives, all profits are recorded as positive, and then all break-even are recorded as 0. So look at how we started. Natural numbers. We say the accounting numbers starting from 1, 2, 3, 4, and so on. So positive. Then we move to whole numbers. We said whole numbers will have to start from 0, 1, 2, 3, and so on. So it's like to get to whole numbers, you have to add break-even situation to profit situation, combination of 0 and the positives. Now we want to move to integers, I. And I was about to give you the definition and I jumped here. Now let me give you the definition and I'll come back to what I'm doing here. Now, integers by definition are both positive and negative whole numbers. So integers are also an offshoot of whole numbers. If I write negative 0, 1, 2, 3. Now watch it. The first one were only positive numbers starting from 1. Natural, whole numbers, W. We added 0 and it became whole numbers. Third, we are now adding the opposites of the positive. I have positive 1 here, I have negative 1 here. I have positive 2 here, I have negative 2 here. So the moment you combine all the 3 scenarios of business, running losses, breaking even, making profit, when you put all those range of figures together, you have integers as the third number system. Integers as the third number system. So far we have generated 3 of the numbers, and this is what I want to show you here. Natural numbers are counting numbers starting from 1. Whole numbers are a set of natural numbers that we include 0. Integers are both positive and negative numbers put together, and that is what we are having here. So 1, 2, 3, I'm sure you understand that this is an offshoot of natural numbers. Integers have also become an offshoot of whole numbers. So we are left with the last 2 to complete the family of numbers. Let's then turn our attention to the last 2 and then complete what we are doing for the number system. So the last 2, let me take the 4th one. This is 1, this is 2, this is 3. Now the 4th one, I did mention rational numbers. Rational numbers. And to help you understand rational numbers, let me use fractions. Fractions are rational numbers. Both proper fraction and improper fraction are rational numbers. And you know how a fraction looks like. If I write 1 over 2, 3 over 4, 5 over 6. Anytime I write a numerator divided by a denominator, it means I've written a fraction. And I want to tell you that fraction is also an offshoot from integers. So when you are asked to define rational numbers or a fraction, all you say is that a fraction is the situation whereby you divide one integer. You divide one integer by another integer. So it means you need 2 integers here to form a fraction. Dividing one integer by another integer. And then you have a fraction. Let's check whether it is true. 1 is an integer. 2 is an integer. So integer divided by an integer, you have a fraction. 3 also qualifies to be an integer. 4 qualifies to be an integer. 3 divided by 4 is also a fraction. 5 is an integer. 6 is an integer. 5 divided by 6 is a fraction. sometimes you can have negative fractions. So I can write -2 divided by 3. -2 is an integer. +3 is an integer. So dividing an integer by an integer, you have a fraction, irrational numbers. So they are also offshoots from integers. So now look at the link. Natural numbers forms whole numbers. Whole numbers form integers. Integers form rational numbers or fractions. Let's end up with the fifth one. Let me go back to our drawing board. The fifth one is irrational numbers. Irrational numbers. So let's look at irrational numbers, how they look like. Now, irrational numbers are also offshoots from rational numbers. And I want to give you an example to understand why they are called irrational numbers. So let's move back again. We are okay with this, we are okay with that, we are okay with this, we are okay with that. This one, I gave you fraction as an example. This one, you have a decimal as an example. So since we are really descending, we are in descending order. Let's see how we descend from this point to this point. Now, irrational numbers, like I said, are numbers that do not make sense on the face value. Okay. Do not make sense on the face value. Let me give you an example. If I write Ghana cedi sign like this, and I write 60.66666, and I ask you 7. I ask you to mention this full amount in words or write this amount in words. How are you going to write this? Are you going to write 60 cedis and 66 pesos or 60 cedis and 66667 pesos? No, it cannot be sensible to appreciate because we know that pesos is of 2 decimal places. Assuming it was 60.66, then we can pronounce it as 60 cedis, 66 pesos. But this one is going way beyond 2 decimal places. And that becomes irrational. We wouldn't know how to pronounce it. How are irrational numbers generated? Irrational numbers are generated when you want to write a fraction as one number. Anytime you want to write a fraction as one number, you are generating an irrational number or a decimal. Let's demonstrate that. We were taught at the lower levels that when you have 3/4 and you want to write this one as a single number, you do long division. So you have 4 divided by 3 like this. And then you were taught that 4 cannot directly go into 3. So you bring some 0 here, and then you put a decimal point here, and then you add a 0 to this one, and then you check again. 4 into 30, you will have 7. You multiply the 7 by 4, you have 28, and then the remainder will be 2. and you were taught that you need to try again to check whether 4 can exactly go through 2, which is not possible. This time, if it's not possible, you were not asked to introduce a second decimal point. You were just taught that add another 0 at the back of 2 and check again. 4 can directly go into 25. And then you multiply the 5 by the 4, you have 20. And then your long division ends because you don't have any number here to continue. And you were also taught to conclude that 3/4 in decimal form is the same as 0.75. In other words, you have been able to convert 2 numbers in a fraction into a single line number of 0.75. You've been able to avoid this division sign is completely taken off so that there is no case of having one number up and then one number below. You've been able to rationalize the two to get 0.75. And that is an example of an irrational number. This one looks pretty simple because we didn't go beyond 2 decimal places. But let's see where the irrational numbers really come to play. Assuming same long division example, I give you another scenario as follows. Let's see whether we can have an easier way again. This time, let's do 10 divided by 3. So we do our long division thing, 10 divided by 3, you have 3 outside, you have 10 here. 3 will be here, 3, that will be 9. You'll be left with 1. 3 cannot be able to go through 1 easily. So you put your decimal point here, you add 0, you try again, 3 will come here, another 3, you have another 9, 1, you still add 0, you have 3, you have 9. So you keep going like that, and you end up getting something like this, which is recurring. You don't know where you are going to end. And that is where the irrationality comes in. That how are we going to treat this number in terms of production or money? Okay, so that is where the irrationality comes in. But thankfully, we have an approach that can be used to deal with the irrational numbers. And we'll talk about that approach later. That approach is called sets. You can use sets to treat irrational numbers to have meaningful results. So students, what we have learned within these few minutes are the family of numbers, which I'm sure you will never forget about them, as well as the processes of deriving them. So always remember that you start with the natural numbers, something will happen to the natural numbers, and then it will transform to the whole numbers. Something again will happen to the whole numbers, and the whole numbers will also be transformed to integers. Something will happen to the integers, and integers will also transform to irrational numbers. And then finally, something can also happen to the irrational numbers, and it will transform to irrational numbers. These are the basic components of the real number system that are used to solve real world or real life business problems. And so when you see me write them, you should know whether I'm dealing with natural numbers I'm dealing with whole numbers. I'm dealing with integers. I'm dealing with rational numbers or irrational numbers. And that is the first information I want to give you. Now let's see their structure, how they look like, whether we can make sense out of a lot of them. I have a question here I want us to look at to make sure we are on the same page. So let's pick this question. When you are asked that which is bigger, look at these two values, 0.6, 0.09. When you are asked that which is bigger, what do? These are two numbers. So anytime you are given decimal point numbers, if you want to see which one is bigger, just multiply it by 100%. And you have an idea of which is bigger. So on your calculator, when you multiply this by 100%, you will end up getting 60%. When you also multiply this one by 100%, you will have 9%. So it means that between 0.6 and 0.09, 0.6 is the bigger of the two. Now, sometimes within the same decimal numbers and decimal places and approximations, you can be asked to do certain approximations I want to remind you of when it comes to either whole numbers or natural numbers or integers. When you are asked to run off 246 to the nearest 10, it means that make sure that the last number or the last digit, if I should put it that way, will end with 0. Make sure the last digit will end with 0. So if you have 246 to the nearest 10, you target your last digit this way. We want to make 6 0, but 6 is greater than 5. And on the number line, anytime a number is 5 or more, what you do is that when you are truncating, you add 1 to the previous number before you truncate. So if we are truncating 6 to the nearest 10 to make this 6 0, because the 6 is greater than 5, we add 1 to this, and then we have 5. So when you combine the 3, you have 250. Okay. We do same thing here for the second one. The second one, this is a typo error. The last number here is also supposed to be 5. If you have 1, 2, 5, 5, and you target the last one to change this 5 into 0, because you have 5, you add 1 to the 5 here, it goes to 6. And then when you combine all, you have 1, 2, 6, 0. Let's pick the last one. if you are to change this one to the nearest 10, you truncate it because you are dealing with only 1 0. We convert this 5 to 0. And because it's 5, you add 1 to the 4 here. It changes to 5. And then the others follow. So you have 1. You are asked to convert to the nearest 100. This is 10. What if you are asked to convert it to the nearest 100? How do you handle that? It means this time they want your last 2 digits to go to 0, 0. So let's start with the first one again, 246. We want to change the last 2 digits to 0, 0. So we truncate it at this point. Now, this goes to 0. Now, this will also go to 0 in one situation, and you can have 200 like this. Somebody will say, I have over 200, so 246. Another person can also take it this way, 246. We truncate. So we start from the back. This, you need to add 1 here, and then you have 5. And then this 5 will also have to go to 0. And because it is 5, you add 1 here and becomes 3. Now, when you push this one to 300, it doesn't make more sense than the 250 because 46 and 300. Look at the difference, 246 and 300. You need more here, as much as 54 before you can get to 300. So some people truncate it starting from the front, 0, 0. Others also come from the back. When the unit you have before the last number is less than 5. So these 2 situations can apply in cases like this. But when you have a simple case like this one, let me even use the 96. If you have a simple case like the 96, and they say approximate 96 to the nearest 100, it means how closer will 96 get to 100? You need 2 zeros. So if you need 2 zeros, this one will go to 0. You add 1 to this one, you get 10. This one goes to 0. And then the 1 comes here, and then you have 100. That is closer to 100. So as for approximation, depending on how you want to do it, you can either get closer to the last number or you come earlier than the last number. Like the first case we have, 246, somebody may approximate it to 250 using the nearest 10. In the same vein, 246, somebody may approximate it to 200 because the 46 is less than half or a quarter of this one. Somebody may also push it to 300, depending on where you are standing and how the magnitude is used. So when it comes to approximation, you have 25.66, you have 24.99, Somebody will clear off this pesos because it is 66 pesos and say, I have only 25 cedis. Somebody may also see that the 99 pesos is closer to 1 cedis. So the person will say, I have 25 cedis. So question, 25 cedis, 25 cedis. Is 25.6 the same as 24.99? No. It is approximation that is making them come closer. So sometimes decimal places and approximations are very important when you are running off figures, depending on what you are looking at. And I'm sure if I write two amounts like this, 25.99, and then I write Ghana cedi 25.99. I'm sure you can easily forget about the 0.99 of the cedis, but you will not throw away the 0.99 of the dollar because of the weight that one has over the other. So the decimal places and approximation also depends on the magnitude of what you are doing. Now, as a result, you may be asked to certain decimal places because of the weight of the number. So sometimes if the number is not too weightier, they will tell you do it importance like the dollar sign I showed you. You may be asked to do it into two decimal places. And so I want us to use this sample problem to learn how to convert decimal numbers into several decimal places, whether one or two, where you stand and how you do it. So for instance, if you pick the first one, if you pick the second one, if you pick the third one, if you pick the fourth one, if you pick the fifth one, they are all different arrangements or structures of numbers. So we are doing it one after the other. If I pick this one, 453.438, for one decimal place, it means that look at the decimal point and then just truncate after one this way. So then you check. This are off. Just one decimal place. We don't want to see more than one. So this, because this is less than 5, we don't need it. All goes to 0. And then we end up having 453.4. These are one decimal place. If you're asked to do the same thing to two decimal places, the two decimal places is different. So this time you truncate not at 4, but you truncate at 3, where you have the 3. So our line comes this way. We have to get rid of this. We add 1 to the previous one, and then this 3 changes to 4. So our new figure becomes 453.44, which is different from the first one. So this, if you pick the D part, one decimal place, you have 0.0678. Now watch this one. One decimal place, you truncate just 1 point after the decimal place. All this, we are pushing them off. But because this is more than 5, you add 1 here, and this one changes. to become 0.1 for the 1 decimal place. What about 2 decimal places? If it is 2 decimal places, it means that this time we don't truncate here 1, 2, we rather truncate at 6. Because 7 is also more than 5, you add 1 to this one and it changes to 7. 0.07. Now look at it. 2 different results. One is bigger than the other. Why? It's because of the way we were doing the decimal places. Because of the way we did it, the 1 decimal place is now bigger than the 2 decimal places. But if you look at the first one, this is bigger than the 1 decimal place. So depending on the kind of figures you have, the decimal place is very important. If you don't apply it well, you are going to lose a lot of money. Let me just give you an example here. Assuming you are selling something, 453.44, but you ended up selling it at 453.4. It means for everyone you sell, you are losing 0.04. Assuming you sold 1 million of that item, let's look at the money you will lose. When you multiply 0.04 by 1 million, you end up getting 40,000. So even though the 0.04, which is 4 pesos, is an insignificant amount, when you multiply it by a huge number, it becomes significant. So decimal places are very important and you must learn how to apply them appropriately. Now let me do the last thing and then I'll open the floor for you to ask your questions. The last thing I want to do today are significant figures, which you know already. Now, significant figures are different from decimal points. They are also used to measure business activities. And if you don't apply it carefully, there are different forms of the significant figures. One of them is called the non-zero digits. This non-zero digits is always significant. Now look at this figure. You have 103.230002. Now, why is the non-zero important? Because if you look at the positions they are, if they are not there, the values will change. Assuming you don't have this 3 here, it means this whole thing is going to reduce to be 10.2. If you don't have these zeros also here, the 2 will let this one change to 10.232. Now, these two numbers are not the same. They are not the same. So there is some significance coming in from some of the numbers. And so the numbers in red are very important because if you change their position, everything changes. Just imagine if I bring 3 first and I bring 1 second. The same numbers, but I've changed the arrangement. Look at what has happened. It has changed from the hundreds to the 300s. It means that the position of 1 is important. The position of 3 is also important. If you change them, you make a mistake. Can you imagine you recording 103 and then you ended up recording 301? You have changed it. Okay. Because 1 is significant, 3 is also significant. Then we have another type whereby you have final zeros, or you have zeros ending. When you have zeros ending, they are also significant. You can't say they are not, because 12.740 is entirely different from 12.74. This is 3 decimal places. This is 2 decimal places. And so final zeros cannot be ignored. They are also important. And then sometimes too, you have zeros in between, like we saw in the first one. The zeros in between also, they are important. The first one, we were looking at 103. I only spoke about the 1 and the 3 by swapping them to be 301. I didn't speak about the 0. But the 0 is also important. If you move the 0 out, this figure will reduce to 31. So it means that 0 is also significant. Now, all we are trying to learn is the position of 0 and the other counting numbers are always significant. Numbers are significant. But there is one last thing that is not significant, and that is where we have to watch out in our business calculations. Now look at this number. 3333. This is not significant. Why is it not significant? Watch this one. If I'm reducing this one to 1 decimal place, I'll have 0.0. If I'm reducing it to 2 decimal places, I have 0.00. 3 decimal places, 0.000. So all these zeros are not doing anything, because when you push all this in the calculator, it will give you 0. If you go again, 4 decimal places, 0.0000. So this thing you are seeing here, is equivalent to 0. And this is not significant for us if we want money. You can't see that you have sold something and you have 0 money. Time you see zeros coming in for just spacing the decimal points, they are not significant. But then if you see it like the previous one we saw, where the zeros are coming in between numbers, then it means they are very, very much significant. Now, how do you finally represent significant figures when you are using a decimal point? The first one is okay. If you start with 0.247, at least before the decimal point, there is a number, which is 0. After the decimal point, there are numbers. So this is a good structure. When you come to the second one, this time you have 0.0042. Same thing. Before the decimal point, you have 0. After the decimal point, you have other numbers, 0, 0, 4, 2. So it means that you have also represented this one well. But when you are doing your calculation and then you just write dot or point 873, after the decimal point, you have a number. But before the decimal point, there is no number. This is a wrong way of representing significant figures. You always have to start with a number before the decimal point, a number after the decimal point. Let me just do one example because of time so I can open the floor for questions. We want to now look at the difference between decimal places and significant figures. And then I'll end with this one. Then you can ask your question. Let me just do this example. When you are asked to do this to one decimal place, like we learned, your target is the first number after the point. You truncate here, and then this becomes your answer. No problem with that. When you are asked the same question to do 2 decimal places, it means you count the first 2, 1, 2, and then you truncate after the last number. But because 8 is more than 5, you quickly add 1 to the previous digit, and then it changes the 3 to 4, and then this becomes your answer. No problem with this one. What about significant figures? When it comes to significant figures, instead of doing it like the decimal point, we will not work like the decimal point. For these significant figures, we start from the front. We don't start after the decimal point. We start from the front. So if you ask me to change this one to one significant figure, I do my truncation here like this. This 2 is no more than 5. So everything here goes to 0. Unlike the decimal points, whereby when you throw the 8 away, you don't add anything to this after adding the 1. This one, once you throw all this away, you add the 3 zeros, change the 2, the 1, and the 5 to 0, because your significance or your I is on the first number. So all other things here go to 0 because the number here is less than 5. So everything goes to 0. What about 2 decimal? What about 2 significant figures? The front, you count 2 numbers, 1, 2, and then you truncate it. When you truncate it, look at the number behind the bar. 1 is less than 5, so they all go to 200. Same is used for the others you are seeing, but because I have only 10 minutes, I want to really open the floor for your questions. If you have any question, please, you can raise your hand up and then I can address the question. Any questions so far from what we have done? Any questions so far? Are you all okay with what we have done so far? If you have a question, please put up your hand. I hope you all know how to use the Zoom tools. If you have a question, put up your hand. All right. So whilst I wait for Abraham, unmute yourself and ask your question.
All right, sir. Thank you. Please,
Abraham, can you speak up?
yes, can you hear me?
And it's not too clear. I'll manage. Go ahead.
All right. Let's say um, we are asked to put a number in. Is there a scenario where a number is in, let's say, 100, and then asked to bring
Hello,
this in?
hello, Abraham. I didn't get it.
Yes, so let's say you are given a number like 123.
Okay, let me write it. 1, 2, 3.
So
Yes.
this number is in hundreds, and then you are asked to bring it to the nearest thousand. Like, is there a scenario like that?
Like you are changing, yes, changing 1, 2, 3 to the nearest thousand. Yes, there's a scenario like that. So when you are changing 1, 2, 3 to the nearest thousand, what it means is that the last digit should be 1,000 digits, meaning 3 zeros. So when we start looking at this one for the nearest thousand and we change, so what we do, this is less than 5, 0. This is less than 5, 0. This is less than 5, 0. So we have our 3 zeros now. Our numbers are finished. So if our numbers are finished, it means that we can't even write 1 here. It means we write another 0. Therefore, the conclusion is that when you're asked to change 1, 2, 3 to the nearest thousand, the answer is 0. Abraham, did you understand that?
Yeah.
Yes. So that is how it works. But assuming your same example, you give me this 1, 2, 3, 0 to change to the nearest thousand. Then same procedure. This is less than 5, so 0. This is less than 5, so 0. This is less than 5, 0. So we have our 3 zeros now because thousands are 3 0. We have our 3 zeros now. So we join it with our last digit here, 1. So then it becomes 1,000. If you ask us to change 1, 2, 3, 0 to the nearest thousand, we have 1,000. And that makes a lot of sense because 100 cannot in any way change into 1,000. It is not possible. But it is rather possible that 1, 2, 3, 0 can change to 1,000 because this can reduce. This one can reduce and you get to the 1,000. But for this one, 1, 2, 3 cannot keep reducing to get to 1,000. It's not possible. It will rather keep reducing till it gets to 0. That is the idea. Mhm.
Thank you, ma'am.
Right. That was a good question. That was a good question. Okay, Stephen, unmute yourself and ask your question.
Good morning, sir, and good morning, class.
Good morning.
Sir, please with the decimal number or decimal place.
Yes.
Sir, please, what about when the number is 450.999, running to 3 decimal
Okay.
places?
Okay. So let's do that. 450. Let me quickly write it and then we work it out. 450.999. Is that the number?
Extra 9
Okay.
to
And
3
then,
places.
and then you are asked to change it to how many decimals? decimal places?
Three.
Very good. Okay. So 3 decimal places, let's use our technique. 3 decimal places means that we start counting from the decimal point. So we have 1, we have 2, we have 3. So we do our cutting here, the 3 decimal places. Now we need to throw this 9 away, but because it is given, we just add 1 to this 9. We add 1 to this 9, it becomes 10. We can't write all the 10. So we write 0 here, and then we carry the 1 again to the back. That will become another 10. We write 0 here. We carry the 1 again to the back. It becomes 10. We write 0 here, and then we carry the 1 again to the back to become 1 here. And then we add our 4 and 5. So this to 3 decimal places will become 4, 5, 1 dot triple 0, like this. This will be the answer. Yes, Steve, yeah. Are you okay with that?
Okay, sir. Okay, sir. Yes, please, sir.
So always keep to the principle. Just count and then start coming back, and you'll be okay with that. That was also a good question. So I encourage you to be asking questions when you are not too clear in your mind about any of the concepts. Unfortunately, our time is up. Start wasn't anybody's yesterday that we were supposed to start at 8, and he said that was the information he received, and I said no. According to the timetable, it's 7. So I'm sure most of you were confused that it will start at 8, but officially it is rather starting at 7 a.m. And then those who joined later, I told the earlier students that you were supposed to be doing Introduction to Business Administration with Dr. Gladys Nkrumah from 7 a.m. to 9 a.m. on Saturdays. But there has been some change in the timetable. So I'm rather taking her time on Saturdays from 7 a.m. to 9 a.m. And then she will take my time at 11:30 to 1:30. So that is the new change for you. So please, on your timetable, don't see Introduction to Business Administration as your first course on Saturday. It's rather Introduction to Mathematics. We can start on time, and your participation, and it's been impressive this first day, and I hope you all the best in the rest of the courses for the day. The class is officially ended for today.